Good afternoon. I am Dr. P. Usharani, Professor RMT Engineering College. I am going to brief about the topic of Thyristor-Switched Capacitor TSC. In power system, reactive power plays a major role. This reactive power control is very important. So various compensators are used for this purpose. The main thing is static war compensator, that is SVC, which is used for supplying or generating the leading and lagging VARs. So static war compensator is the exchange of capacitive and inductive currents to the power system. For this purpose, two devices are used. One is thyristor-switched capacitor, another one thyristor-switched reactor. The thyristor-switched reactor absorbs reactive power, whereas thyristor-switched capacitor, this one has supplies or generates reactive power. So generally this type of reactors, if you see the diagram, actually two anti-parallel ACRs which is connected to one capacitor. This is the circuit diagram of this shunt connected device. So their effective reactances varied in a step-by-step manner by adjusting the conduction angle of the thyristors. Here there won't be any firing angle control. Kindly listen. There is a here by adjusting the conduction angle of the thyristors, the effective reactances varied in a step-by-step manner. So actually what happened is the thyristor switches are used to connect and disconnect the capacitor to supply the required reactive power to the power system. Practically, to limit the current here, we have inductor present, practical circuit. What is the purpose of this inductive, that is inductor? In this case, if you take care to limit the current transients during over voltage conditions. So practical circuit consists of inductor here. So there is three parts, that means. So one is the capacitor. This supplies reactive power to the system. And the second one, the bidirectional thyristor valves to connect and disconnect the capacitor to the system according to the requirements. Okay, third one is a current limiting reactor to limit the surge current in the thyristor valve under faulty operating conditions and avoid the resonance with the power system impedance and the frequencies. This is the basic circuit diagram of thyristor-switched capacitor. We will be going for the operation when the TSC is off condition and TSC is on condition. In the case of thyristor-switched capacitor is in off condition. If you take care, there won't be no flow of current. That is, there won't be no current in the thyristor-switched capacitor. So the voltage is supported by the thyristor valve. If the TSC is switched off for a long time, then the capacitor fully discharged and valve experiences the AC voltage of the SVC bus. So we have seen here three voltages. One is AC system voltage, okay, this one blue color, and capacitor voltage in green color, and reactor voltages this one violet color. Okay, accordingly the current valve voltage and valve current, that is thyristor valve current is till capacitor as on means is there, off means there won't be any current in the TSC. That time voltage is present. So the TSC as turns off means there is no flow of current, and the corresponding the capacitor voltage is peak value. Okay, and the capacitor discharges very slowly. So you should take care of that one. Second case, when the TSC is switched on. Switched on means we have valve current as present. Okay. So, and then you have the reactor voltage is present here. Okay. And you have seen the capacitor voltage till that, and then the sinusoidal shape comes. Okay. That is when the TSC is switched on. Which is having a resonant circuit. By seeing the connection, you have inductor as well as capacitor. So TSC as a resonant circuit, there will be sudden shock. Okay, so very oscillatory currents flows. So that means it will produce a high frequency ringing effect, which affect the thyristor valves. You should take care of the analysis of current transients after closing the switch. So there is two cases here. Okay, when the thyristor switched capacitor is on means due to inductor and capacitor, it forms a resonant circuit. So oscillatory current flows. So there is two cases here. First case is the capacitor voltage is not equal to the supply voltage when the thyristors are fired. So if you close the switch immediately means a infinite amount of current flows and charges the capacitor to the supply voltage in a infinitely short time. So that means the switch, that is the thyristor valves, cannot withstand this type of stress, and what happened is the effect is the switch will fail. Okay, that is the drawback of that. Case 2 is if the capacitor voltage is equal to the supply voltage when the thyristors are fired. So that time the analysis shows the current will jump immediately to the value of the steady state current. The steady state condition is reached in an infinitely short time, as well as the magnitude does not exceed the steady state value, but thyristors have a limit. You know that the di by dt protection as well as dv by dt. Here we should take care di by dt. So they can withstand during the firing process. So you know that di by dt of the thyristor valve is infinite. The thyristor again would fail. Okay, there is a drawback. For that only practical cases, whatever I have explained till now, it's a combination of thyristor switch turned on and thyristor TSC has turned off. Okay, that same diagram only with the combined one, turned on and TSC turned on and turned off. So practical circuit, to limit this, we are including inductor. Okay, to limit the current, a small series inductor is installed. So these are the three parts. This is SVC family thyristor switch capacitor which supplies reactive power. Thank you.